Let's discuss an important branch of mathematics that is applied in many fields, whether it be pandemics, tracing, whether it be teachers and marks of students reporting on that, and in many jobs where you have to do some sort of reporting on how things went, whether it's in the retail industry, you've done sales, how are your sales going, when are they increasing, when are they decreasing, why haven't you met your targets, all those kind of things. Statistics is a very important subject that we need to cover for many fields to come. So we are just going to look at what we call data handling, the part where we're just dealing with the basics, but all the way to key interpretations that are applicable to the real world. So first of all, in statistics or data handling, you have to collect the data. So that's our step one. So you would need to go out, collect the data. It could be in the form of doing surveys, interviews, or questionnaires. That's how we can get what we call raw data. Then after that, you would need to go ahead and sort the data in order to make it easier to read. So in some general cases, you'd be factoring out unimportant data, but generally we'll be doing arrangement in ascending or descending order for the academic purposes. Then once that has been done, then we have to represent the data in a way that is easy to read and analyze. So the representation could take the form of a summary of the data, tables, charts, or even graphs, because that makes it easy to actually read. Once that has been done, we will go ahead and do what we call interpretation of key values. So there are some key statistical values that are going to be used. Some examples are the mean, which is actually the average. Which is why in the report card of students, there is the mark of the students and there should be a class average there, because what it's doing, it's telling you how your child or how you are performing in relation to the population in the class. So that is why when students come to us for extra classes, I always ask for that report card to say that as much as a learner got 30%, let's say, but if the class average is 15% or 20% or 28%, that tells me something. It tells me that this child has got marks that are more than 50% of their classmates' marks. Now this tells me that the struggle of the child is not necessarily their capacity to understand, but more of their not understanding in the environment that they've been put in. Now we are going into the interpretation and summarization of data, so summary and interpretation. We are first going to look at 5 numbers that are key in analyzing data given. The 5 numbers are called the 5-number summary. So it's a summary of 5 numbers that gives very important information about the data collected. So what will happen is, you could find yourself, we'll do it by example for the sake of easy understanding, because if I just give you the terminologies, it doesn't really make good sense, but when you see it with an example, then it just makes better sense, and you also get to see how to get those numbers. So let's say we are given a data set like this that has already been collected. That's a group of 11 numbers: 63, 79, 50, 75, 75, 66, 150, 86, 72, 74, and 60. Then one thing we will definitely need to do is to arrange them. So this is what we call arrangement in ascending order. Ascending order means from the smallest one to the biggest one. All of them written, none left out. So we can also have descending order, but we more work with ascending order. So one of the most important numbers that we will want to know is what is the smallest number of them all, because this tells a good story about the numbers. So we will want to know what is the minimum. So part of your 5-number summary, the minimum will be there. Then, as opposed to that, we will want to know what is called the maximum. So what is the highest number collected in the data set or present in the data set? So number 5, we'll put it as maximum. On top of that, we will then want to know which number appears in the middle. This is called the median. So we want to know which number appears in the middle. It's called the median. So what you do is that when you check your numbers, you can do the finger analysis when the numbers are not too big. I'll show you a formula that you can also use to find the exact position of the number. So here we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then 6, and then 7. So what we will have is that the middle number will be at number 6, because then it splits the 11 numbers into 5 this side, 1, 2, 3, 4, 5, and 5 this side, 1, 2, 3, 4, 5. So this here is our median. So that would be our median right there. So our median in this data set, let me just put them here. This would be 50. This one would now be 74. This one is 150. Then the median has divided the data, very importantly for you to know, into 50% below, which is why I was saying that knowing the median can help you explain quite a lot, and 50% above. So that's the median of the data. So from there, we will look at two more important terminologies and numbers. We call this one the lower quartile. So the lower quartile, which we will refer to as Q1, is the number that is the half of the lower half, or 50%, let's say, half of the lower 50%, the center number for the lower 50. So because there's 5 numbers here, our lower 50 will be at number 3, so that will be our Q1, because we have 2 this side and 2 on the other side. So that's what we call a lower quartile. It cuts the number into the first quarter. Then we have a upper quartile as well. So the upper quartile is the half of the upper 50%. So that's the upper quartile. So in this particular case, here we had our 63. Then in the upper quartile side, we would then have our 79 as Q3. So that gives us 79. So again, this tells us that when we look at our upper half, the middle of the upper half is 79. Now, this information can be used to sketch what we call a box and whiskers diagram. It's a diagram that represents the 5-number summary, so it goes hand in hand with questions to do with the 5-number summary, and then it gives a distribution analysis. It shows us how distributed the numbers are. How far is the minimum from the maximum? How far is the maximum to the median, and things of that nature. There's a lot of analysis that can be done, but we will focus on the range and the interquartile range only for now. Therefore, now when sketching the box and whiskers diagram, it is very important that you start with a scale. So you present a scale first before putting the numbers on the box and whiskers. So the scale here works in counting in 5s. I started it from 45 just for control. I know I could have done 50 as well, but it's fine. I counted in 5s because I feel that's the best way to represent as much of my numbers as possible. 10s would give me a too big a gap between numbers, but of course you can use others. If I use 1s on the other hand, I could not fit them on the board, or you would not be able to see them. Then what do? You first draw a line where the minimum is. So where the minimum is, we will have a line like this. And then we will draw a line where the lower quartile is. So lower quartile is at 63. So between 60 and 65, we will have 61, 62, 63, 64. At 63 here, I will have a line. It will just be a bit larger because it's part of our box. Then we go and look for the median. The median is at 74. So that means that at 70, so we have 71, 72, 73, 74, our median would be here. Then we have the next one, which is the upper quartile. The upper quartile is at 79. So 79 would be here at 76, 7, 8, 9. So 79 would be right here. So now you will see that we have completed our box. This is called the box section. So what it has is the Q1, the median. The median is also referred to as Q2 because it splits the data into 2 equal parts. This one is the lower quarter, and then Q3 will be right here. But now here's the issue. We have a maximum all the way at 150. We will represent it, but you can see that it is quite far from the rest of the box and whiskers. However, that would be our box and whiskers diagram. Then we just connect the whiskers. So the whiskers go to the minimum and maximum. So here we are saying that there's a skewness in the block, and that is normal. We'll do the analysis later. But what I want you to really understand is the following. The 5-number summary, given that this is the minimum and this is the maximum. What it does is that it has cut the data into sections of 25%. So this is 25% of the data below the Q1, and then there's 25% of the data between Q1 and Q2, because remember, from here to here we have 50%. So from here all the way to here, there's 50% of the data. Then we have another 25 here and another 25 there. And that gives us another 50% of the data, because the median has cut the data into 50%. Which is why I was saying, if somebody comes and says that the median of a class is 30%, it automatically means that 50% of the learners have below 30%. 50% of the learners have above 50%. If the Q1 or lower quartile is 20%, it means that 25% of that very class that we're speaking of has gotten below 20%. If the upper quartile is at 40%, that means that 75% of the learners in the class, because that would be the 25, 25, and 25. 75% of the learners in that particular class have gotten below 40%. So only 25% have more. So this is the kind of analysis we can do with the box and whiskers diagram.